Hello everybody, and welcome to this video on scientific notation. This is basically how you take very large and very small numbers and put them into a scientific form that everybody understands, and it's easier to put it into your calculator when you have a lot of zeros. Sometimes you can't even get that many zeros into your calculator. So that's our objective for this video today. Hopefully you have already watched the video on significant figures, because that will come into play here. I'm going to assume you already understand significant figures and how those work. Okay? So let's start off with something relatively easy, the distance between the Earth and the Sun. Okay, a lot of people call it 93 million miles, 1 astronomical unit. Here it is in kilometers. Okay, you don't want to put all those zeros in your calculator, and you don't want to express it that way. 150 million kilometers. We want to put it as 1.5 times 10 to some exponent power. And you get the exponent power by understanding, first of all, there's a decimal at the end of this number. It's assumed to be there, we just don't write it. Okay, so to move that decimal to the 1.5 position, you're going to go 1, 2, 3, 4, 5, 6, 7, 8 loops over to the left. So 1.5 times 10 to the 8th kilometers is how you put that as scientific notation. So that's taking a very large number and putting it in a form. We can also go the other way. We can take a very small number and put it in scientific notation. I would want to write that number as 1.4 times 10 to some power. Okay, but this time I'm moving the decimal to the right, so it's going to be to a negative exponent. So 1, 2, 3, 4. So 1.4 times 10 to the minus 4 meters is how I would write that one. Okay. Another example. Why don't you try these two on your own? Pause the video for a second, see how you do on these, and see what you come up with. All right, so this first one, I want to put it as 3.82 times 10 to some power. So here's the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I counted that right. 2, 3, 4, 5, 6, 7, 8, 9. Yep. So 3.82 times 10 to the 11th power. That's how you would put that in. And here's a very small number, so I want to put this as 3.5 times 10 to some negative power. Let's see what it is. 1, 2, 3, 4, 5, 6, 7. And there you go. So there's a couple examples. You should get the hang of that now. Let's do some important applications. Most people can put these numbers in scientific notation without a problem. Where they struggle is putting those values in your calculator. I want to be very explicit on how to do this. There's a right way and many wrong ways to do this. So a lot of times people try to use the caret key, which you shouldn't use. Sometimes students try to write times 10 in their calculator and then do this function, and what that's doing is it's doing times 10 2 times, which really changes everything here. It's much easier. Just follow these steps and you'll be fine. Most people are using TI calculators. So anyway, if I'm going to put this in scientific notation, that's going to be 3.5 times 10 to the, let's see, if you count all these digits here, it should be to the 8th power when counting that over. So if I'm going to put that in the calculator here, what I want to do is I want to hit first 3.5, enter in the, that's called a Matisse, the number in the front. Don't hit times 10. You want to put this in scientific notation in your calculator. For this particular calculator, you're going to hit second function, and then come over here and you'll see the comma key. Now right above the comma key is double E. That's scientific notation symbol. So you've engaged that function by hitting your second function. So you want to hit 3.5, and then you want to hit second function. So second function key, and then the comma, double E key, and then just simply put in your exponent, 8, and you're done. Don't put in times 10, because then you'll be telling your calculator to do that multiplication twice, which, that's going to make it to the 16th power. You don't want to do that, okay? Entering in this number, which is a negative exponent, that's going to be 3.4 times 10 to the minus 4 power, okay? So to put that in scientific notation, you simply put in 3.4. You're going to hit second function, and then you're going to come over to that comma key above it is double E. That's your times 10 power. Your calculator's already got that programmed in. Now put in -4. Don't hit the minus key. Nope, that's not the right one. This is your negative key. So you want to go to that, -4. Sometimes you have to hit 4 and then the negative key, depending on the order of operation of your calculator. It's the same with this calculator here, but you don't have to hit second function. It's got double E programmed as its first function. So you do everything the same, except you wouldn't be doing second function. You simply hit 3.4 and then that double E key. Here's your negative key, and then put in your exponent 4. And bingo, you've got it in. Okay, so let's give it a try. Here's two simple calculations, numbers that are already in scientific notation. Pause the video and see what you get on these two, and we'll come back and check your answers. All right, so after we've multiplied these together, this is what my calculator gives me. And then we're going to look at sig figs after this, okay? 1.736 10 to the 13th. All right, this has two significant figures. This has two significant figures. My answer should only have two significant figures. So the 36 is dropped. My final answer should be 1.7 times 10 to the 13th. The exponent has no bearing on the number of significant figures. Those are just placeholders. It's these numbers in the front that determine the number of sig figs. And trying the one below, my calculator gives me 1.029 times 10 to the minus 18th. That's got 4 sig figs there. My answer can only have 2 sig figs. So that 29 doesn't round the 0 up to a 1. It simply gets dropped. So 1.0 times 10 to the minus 18th. There's my final number. Okay, so make sure you can enter those into your calculator correctly. We use large and small numbers all the time in physics, especially when we do units on astrophysics and gravity. In chemistry, they use very small numbers all the time. So it's something you use all the time in science. You want to be proficient at it. You may have to watch this video a couple times to master this technique. So anyway, I hope that answers your questions, and practice this as many times as you need to, and have a great day.